All right, good morning. Today we're going to talk about multiply and divide monomials. So this is chapter 1, lesson 3. A blank is a number, a variable, or a product of a number and one or more variables. In that blank, you're going to write monomial. So a monomial is a number, a variable, or a product of a number and one or more variables. You can use the law of exponents to simplify monomials. So basically what that means, come down here a little bit further, there's two that we're actually going to be talking about. So the first is the product of powers rule, which basically says that I can take the exponents as long as they have the same base and add the exponents together. So 4 squared times 4 to the 4th power would give me 4 to the 6th power because 2 plus 4 gives me 6. Okay? And here it is in algebraic force. So a to the m times a to the nth equals a to the m plus nth. I also have the quotient of powers rule, which tells me if I have any two monomials with exponents, okay, I can subtract their powers as long as they have the same base. So for any non-zero number and any integer x and y, so a of x over y of a of y equals a to the x minus y. Okay? So we have a couple of examples down here to look at. Zoom in to make sure y'all can see. So the first one is simplify laws of exponents. So I have 5 squared times 5. Well, 5 squared, I can use the product of powers rule, like we did up there. So that tells me 5, because they both have the same base, 2 plus 1 is 3. So I have 5 cubed, 5 to the 3rd power, or 125. So remember when we multiply exponents, we do whatever the base is, we multiply that base times itself by however many exponents we have. So 5 cubed would be 5 times 5 times 5. Okay? The second one we have is c cubed times c to the 5th. So we can add the exponents together because they have the same base. 3 plus 5 gives me 8. So I have c to the 8th. For number 3 down here, I have negative 3x cubed, negative 3x squared times 4x to the 5th, okay? So they have the same base, they still have the same base of x, so I just multiply the whole numbers together. Negative 3 times 4 gives me negative 12, okay? And then I look at the exponents. They both have the same base, so I can add the exponents together. 2 plus 5 gives me 7, so my final answer is negative 12x to the 7th power. Be really careful, guys, with your negative and positive numbers when you multiply them. A couple of times that has been an issue for some of the other ones, all right? Then I have 4 and 5 over here. Same idea. So I have 4 to the 5th over 4 squared. Well, they both have the same base, so that's an 8. 4 to the 8th over 4 squared. So 4 to the 8 minus 2 gives me 4 to the 6. And when I multiply that out, I get 4,096. Number 5 tells me n to the 9th over n to the 4th. Same base, subtract the exponents. 9 minus 4 gives me 5, so n to the 5th. Okay? Number 6 down here, it's a little bit more complicated, but it's still the same ideas, okay? So I have 2 to the 5th times 3 to the 5th times 5 squared over 2 squared times 3 to the 4th times 5. Now you can do one of two things. You can either just multiply everything out because they're all numbers and then simplify, or you can start to recognize that, okay, well, 2 to the 5th and 2 squared, they have the same base, so can I simplify those? Yes, I can. 5 minus 2 gives me 3, so I have 2 cubed. Okay. 3 to the 5th and 3 to the 4th had the same base, so I can subtract them. 3 times 3, 5 minus 4 gives me 1. And then I have 5 squared over 5. Now realistically, this is a 5 to the first power. Okay, we don't have to write the first, it's kind of imaginary. So 2 minus 1 gives me 1, so I have 5 to the first. So 2 cubed is 8, 3 to the first is 3, 5 to the first is 5. I multiply them together, 8 times 3 times 5 gives me 120. Now there's a couple of try it problems here. So I want you to go ahead, pause the video, try the 6 try it problems out, and when you're done, we'll go over them together. All right, now that you've gone over the try it problems by yourself, let's go over the answers together. The first one says g cubed times g squared. So what I'm going to do is I'm going to come over here to my workspace area on the other side. Okay. So you can see it. Make sure you can see it. It's my top of my page. All right, so this is A. So I have g cubed times g squared. Remember the little dot means multiply. So they have the same base, so that's good. So I can just add the exponents. 3 plus 2 is 5. So my final answer is g to the 5th. Okay? So I can come back over here and write g to the 5th. Okay? Letter B is negative 2m times negative 8m to the 5th. Back to my workstation. So B, negative 2m times negative 8m to the 5th. I multiply my numbers, negative 2 times negative 8. So negative 2 times negative 8 gives me a positive 16. Then I have m's here, right? Sorry, this should be inside the parentheses, makes a difference. So 16. So I have m to the first times m to the 5th. Well, they have the same base, so I can add them together. 1 plus 5 equals 6, so I get 16 m to the 6th as my final answer. All right, letter C tells me 5 to the 7th power divided by 5 to the 4th power. Come back over here, try that problem out. So it's, woo, timber. Sorry, we lost the camera there for a second. Apologize. So I've got C. I have 5 to the 7th over 5 to the 4th. They have the same base, so I can subtract the exponents. 7 minus 4 gives me 3. So I have 5 to the 3rd power, which I can multiply out as 5 times 5 times 5, which equals 125. Okay? So for C, you can have one of 2 answers. Your first answer could be 5 cubed or 125. Either would be correct. Okay. Letter D says 12w to the 5th divided by 2w. Okay. So letter D, 12w to the 5th divided by 2w. Okay, so I want to look at the numbers first. 12 divided by 2 does divide. 12 divided by 2 equals 6. Then w's have the same exponents, so that's 5 minus 1. Remember, there's the imaginary 1 here. 5 minus 1 gives me 4. So I'm left with 6w to the 4th power. Then I have letter E. Letter E tells me 3 to the 4th times 5 squared times 7 to the 5th divided by 3 squared times 5 times 7 cubed. So let's try that one out. Okay. E, 3/4 times 5 squared times 7/5 over 3 squared times 5 times 7 cubed. I can notice that these are the same base, so 4 minus 2 is 2. These are the same base, so 2 minus 1 is 1. The 7s have the same base, 5 minus 3 gives me 2. So I'm left with 3 squared times 5 times 7 squared. Okay, when I multiply that out, 3 squared is 9, 7 squared is 49, so I get 9 times 5 times 49, which is 2,205. 2,205 is my final answer for E. Okay, then I have F, negative 2 to the 5th times 3 to the 4th times 5 to the 7th divided by negative 2 squared times 3 times 5 to the 4th. Okay, once again, I can rewrite this and multiply it out. Okay. So I have F notice each time I'm rewriting my problem out, I want to make sure I'm writing it correctly. Okay, so I have negative 2 to the 5th, negative 2 squared, same base. I can subtract the exponents. That's 5 minus 2, gives me 3. 3 to the 4th and 3. Remember, there's that imaginary 1 there. 4 minus 1 gives me 3. 5 to the 7th, 5 to the 4th. 7 minus 4 also gives me 3. So I'm left with negative 2 cubed times 3 cubed times 5 cubed. Okay, really, really careful with this negative 2. It's in parentheses. So it's negative 2 times negative 2 times negative 2. So it's negative 2 cubed gives me a negative 8. So be very, very careful with that, okay? 3 cubed gives me 27, and 5 cubed gives me 125. When I multiply all three of these together, I get negative 27,000. Negative 27,000. Okay? So that is my final answer for F. Negative 27,000. And that ends this lesson on multiplying and dividing monomials.